So what's that distribution look like in the book? Well, I'll take you to the chart in a minute. The student's t-distribution depends upon sample size. And so it changes based on sample size. It has an aspect of it called degrees of freedom. Degrees, or degree of freedom. Degrees of freedom. And when we are working with a single variable, which is what we do pretty much right now, work with a single variable, there's 1 degree of freedom. Now if we work with 2 variables, then there may be 2 degrees of freedom. It turns out that there's a calculation. So for right now, for example, the degrees of freedom, abbreviated DF, will be calculating that as n minus 1, 1 less than the sample size. If there are 2 degrees of freedom, it would be n minus 2, 2 less than the sample size. It's just another one of those little aggravating things that statisticians came up with that makes this subject a little more complicated than we would prefer. However, by doing these degrees of freedom, it allows one chart for the student's t-distribution that's usable depending on the degrees of freedom. So we don't have to have multiple charts for different degrees of freedom. We can have one chart and just calculate whatever is appropriate. So I hope that made sense. It will once we start looking at some examples, which I'll do shortly. So let me look at my book here, get my place. Yeah, let me go ahead and give you an example. Suppose that we had erase the board here. Let's suppose we had a sample of 18. N equals to 18. And we want to know the t-score associated with a probability of 0.025. So what is the t-score for 18 minus 1 equals 17 degrees of freedom, and a probability of 0.025. Alright, well, that may look like a lot of Greek to you right now. What in the world am I talking about? A t-score is analogous to a z-score. It's like the number of standard deviations. So I'm asking this question, what are the number of standard deviations if you had a t-distribution and we wanted to look at, say, this end of it, the top 2.5% or 0.25, that probability. What is the t-score associated with that for n equal to 18, sample size of 18? Alright, so it's asking, again, it's asking a question very similar to, well, how many standard deviations does this represent? You know, it's like a z-score, except it's a t-score. How many standard deviations? Alright, well, the chart, which begins on page 651, for a t-distribution is backwards, organized backwards from the z-distribution. I'll tell you what I mean in a second here when I get to it. Alright, page 650. Let me take you back here. Page 649. 649. If you look at a z-score of 1.96. So I'm on page 649, the normal z-distribution. Look for the probability associated with a z-score of 1.96. Alright, so I'll go 1.96, so I go 1.9 down here. I go over to 0.06 over here, and I find a number. All right, that's the probability. So let me write that on the board. The z-score associated with a probability of 0.025 is 1.96. So now I just said that backwards, didn't I? If you look at a z-score of 1.96, you get a probability of 0.025, 2.5%. So here's the z-score. This is the probability. So notice that probabilities are in the black and white section of this chart. All right, now when you turn the page to the t-distribution, it's backwards. The probabilities are found in the pink, and the t-scores are found in the black and white. So it's backwards that way. That's what I meant. All right, so to answer this question, I'm calculating the t-score based upon a probability of 0.025 and 17 degrees of freedom. Now, again, 17 degrees of freedom, sample size of 18, and -1 is degrees of freedom right now. So 17 degrees of freedom. So see if we can find that in the chart. When you go down the left side of the page, it says degrees of freedom. So look for 17. It's about in the middle, isn't it? And then come over to the top here where it says probability, find 0.025. It's about in the middle. So when you bring these together, you get, let me see, 17 degrees of freedom. 0.025 is 2.11. So that t-score is 2.11. All right, so this question is talking about 2.11 standard deviations, basically. Whereas with a z normal distribution, that's 1.96 standard deviations. So you see the t-scores for the same thing is a little bit higher. This is a little bigger than that. And that's always true with a student's t-distribution. This allows for that extra slop you get by having a sample and not knowing the population standard deviation, only being able to calculate the sample standard deviation. All right, so that's where that comes from. Now, if you're a little worried right now, like how in the heck I'm going to keep all this straight, we're going to work a lot of examples. So try to relax. A lot of examples coming up, starting in Chapter 6, where we do these calculations, and you'll get used to them, I think, in time. Well, of course you will. So, because people do pass this course. So that's a kind of introduction to the student's t-distribution. And let's see what's else left in Chapter 5. We're almost done. They mention a few other types of distributions.